Hey everyone, Mr. Shat here, talk to you about a systems of equations word problem. All right, let's read the problem. It says admission fee at a small fair is $1.50 for children, $4 for adults. On a certain day, 2,200 people enter the fair, and $5,050 is collected. Okay, so the question is asking how many children and how many adults attended. So those are our variables. Okay, so how many children? So let's maybe let C equal the number of children who attended the fair, and let's let A be the number of adults. Okay? So when you're building equations for a word problem, you have to kind of understand what to build. In this problem, we're dealing with two things here. We're dealing with a total number of people who entered the park and total number of money collected. Okay? So one of the equations is going to deal with the total number of people that attended the park, and the second equation is going to deal with the money. So let's talk about the total number of people who attended the park. All the children and all the adults have to add up to 2,200 people. So to represent that, we're just simply going to do C plus A equals 2,200 total people. Okay? So that's equation number one. Equation number two is the total money collected. Well, if each child is $1.50, and we don't know how many went, so we called it C. So that's $1.50 times C. So that's $1.50 for every kid, 1.5 times the number of kids, plus $4 times the number of adults has to add up to $5,050. Okay? We're ready to solve. We can use substitution or elimination. Both seem pretty fitting here. I'm going to use elimination. So let's go ahead and look at C. I've got 1.5, and I need to get rid of the c here. So what I need to do is multiply the top equation by negative 1.5 times by negative 1.5. Okay? So if I were to rewrite the equations, the top one would turn into negative 1.5c minus 1.5a equals negative 1.5 times 2,200 is negative 3,300. In the bottom equation, I do not touch at all. I leave it alone. Okay? Okay. Now, we're ready to eliminate. If we add down negative 1.5c and 1.5c cancel, negative 1.5a and 4a would be positive 2.5a equals 3,300 minus 50/50. Well, let's see here. So if we were to subtract these two things, so it'd be 50/50. I put the larger number on top, minus 3,300. So 0 minus 0, 5 minus 0, got to borrow here. 10 minus 3 is 7, 4 minus 3 is 1. So it would be 1,750. Okay? And then we simply divide that by 2.5. And we get A. Divide by 2.5. Divide by 2.5. And we get that A is equal to, so let's just make that quick calculation, that 1750 divided by 2.5 gives you 700 exactly. That means 700 adults went to the fair that day. All right? But hey, check this out. You know that 2,200 total people went to the fair that day. 2,200 total people, and you know 700 of them were adults. That means that to find C, all you have to do is take the 2,200 total people and subtract away the 700 adults. So 0, 0, gotta borrow. 12 minus 7 was that 5. And 1. 1,500 of them were children. 1,500 children. Okay, so that's how you tackle a systems word problem. I hope that you found that clear.